All right, everybody. I thought I'd do a couple optimization problems with a few different contexts to get you guys a little more experience. So I hope that you can kind of look at the prompt and kind of work on it as you go and pause the movie. So here we go. We have a piece of cardboard that is 30 centimeters by 16 centimeters, and we're going to cut the corners out and fold up the sides to form a box. Actually make this with a piece of paper if you are having trouble seeing it. Determine the height of the box that will give maximum volume. So we know that the volume of a box would be, base times width times height. But that's way too many variables, and we're going to try to take what we know and rewrite it, hopefully, and make it a little bit easier. So if you think about these little pieces right here, if you fold this stuff up, those are actually going to be the height of that box or that kind of tray looking thing. So these are all little H's. And if you're a little bit more creative, you can think about this side as 16 minus 2H. And you can think about this side as 30 minus 2H because you have an H on each end. Again, a lot easier to see if you actually create this with a piece of paper. So the base, you could think of one of these sides, again, as 16 minus 2H. You can think of another side as 30 minus 2H. And then you can think of the height as H. So the volume is going to be our base times our width times our height. I love it. This is a rare example where we have an equation with one variable and we don't actually need a second equation to relate the variables. And so we got a little bit of work ahead of us, but you can kind of tell that this is going to be a cubic because we're going to have h cubed in there, which means v prime is going to be a quadratic, meaning we're going to have a max and a min. And our solution will be found by setting v prime equal to 0. So I'm going to do hopefully a couple more steps, and if it gets really ugly, then maybe I'll let you finish it. But before I take the derivative, I would distribute all of this so you have easier numbers, and then you can just do the power rule. So I'm going to FOIL this out. So like 30 times 16 is 480 minus 30 times 2 is 60. Minus 2 times 16 is 32. And then plus 2 times 2 is 4h squared. And then if I distribute the h in, I'm going to have 480h minus 60h squared minus 32h squared plus 4h cubed. And then if I take the derivative, I'm going to have 480 minus 120h minus 64h plus 12h squared. V prime is equal to 480 minus 184h plus 12h squared. Set this equal to 0. I mean, I'm guessing 12 goes into all this stuff. Let's find out. So if I pull out a 12, I've got 40. Let's see, 184 divided by 12. Ugh, it doesn't go in. Darn it. Leave it like this. And then we have h squared. So if you divide both sides by 12, again, I kind of made it maybe more inconvenient. But the setup, I think, is the trickiest part. So maybe go back to this moment. But if you want to finish this, you can bust out the quadratic formula to get two potential answers. And your maximum will be in there. So I'm going to give you one more example because I don't want YouTube to cut my movie short. But I think I gave you all the good stuff here. So I'll let you finish it on your own. All right, second example, here we go. We want to construct a cylindrical can with a bottom but no top. So I'm going to draw a cylinder that will have a volume of 65 cubic inches. Determine the dimensions of the can that will minimize the amount of material. So I think we're going to need a volume formula. So pi r squared h is the volume of a cylinder. And then minimize the amount of material. So I think we're going to call that surface area. But it says that there's no top. So the surface area is going to be the bottom, which is a circle, plus what's called the lateral surface area. And best way to visualize this is if you take a piece of paper, pick up your homework right now if you want, and you roll it up to form a cylinder, kind of like it would look like a toilet paper roll or something. So it's got no top or no bottom. The idea is the height would be that, and then when you roll it up, meaning move this kind of over onto this, that's going to be the circumference of the circle. And so the area of this rectangle that's forming a cylinder when you roll it up would be 2 pi rh. And if we want to minimize the amount of material, our goal is going to be to find SA prime and set it equal to 0. But currently, SA has too many variables. So that's where the other hint comes in. 65 is a constant, meaning we want the volume to stay 65. And so again, if I set this up, I could say that 65 divided by pi r squared is h. And now I could say that SA, again, that's my abbreviation for surface area, that's what we're trying to minimize, is going to be pi r squared plus 2 pi r h, but h is 65 over pi r squared. And before I take the derivative, I talked about this a little in class, I'm going to try to simplify it first. So this would be pi r squared, and then I'll use another color for fun. I can cross out an r, I can cross out a pi. And so what do I have left? I've got 2 times 65, which is going to be 130. And then the r, I'm going to move up and make it negative. So now I can use the power rule. So SA prime would be 2 pi r minus 130 r to the negative 2. And if I set this derivative equal to 0 to determine the maxes and the mins, let's see if we can crank some of this out. So if I pull out, let's see, an r, I'm going to have 2 pi minus 130 r, what would this be, to the negative 3. This one's kind of weird because when you multiply exponents, which is what you're doing, you're actually adding them. That's r to the 5th. So if I factor out an r to the 1st, 1 plus negative 3 would be negative 2. So one solution is r equals 0, but if you think about that, what would a cylinder look like with a radius of 0? That's kind of an extraneous solution. So I think our answer is going to be found by setting this equal to 0. I think we have time to finish it, but let's finish. Let's see what we get. This is going to be this. Divide by 130. And then the best way to get rid of that, I think, would be to take it to the negative 1/3 power. And I'm a little nervous because I don't have a calculator, but see if I can try to figure this out. I got my phone here next to me. Let's see if we get an answer that hopefully makes sense. So I'm going to try to go 2 pi divided by 130, which is again a really small number, and then take it to the negative 1/3 power. I'm afraid this video is going to be wrong, but I did this on an iPhone. It's the first time I've ever used a scientific calculator on an iPhone, but I got this. So I'm going to stop recording. I think that's the right answer. We could verify that it's a minimum by checking the signs. I'm going to verify that that is a legit answer, but for sure the process is right. So I appreciate you guys tuning in. Good luck. Thanks for watching.